Hello, I am Chen, master's degree from University of Electronic Science and Technology of China. Today I will introduce our work published in CVPR, add-and-bit operation-only hardware-friendly binary neural network. Binary neural networks are proposed to minimize hardware overhead. However, existing mainstream binary networks still require millions of multiplication operations during inference, which is hardware unfriendly. The sources of these multiplication operations include scaling factor, BN layer, RPReLU layer, real value residual, average pooling layer, and so on. A key to eliminating multiplication operations is to remove the BN layer. BN-free BNN applies the normalizer-free technology to the BNN field, or input images with a resolution of 224 times 224 in BN-free BNN. The RLeakyReLU 18 generates approximately 5 million multiplication operations, while the RLeakyReLU A yields approximately 15 million. To completely eliminate all multiplication operations in binary neural network inference, we use the normalizer-free network architecture, the mask layer, and quantized RPReLU unit. Normalizer-free architecture introduced the scaled weights standardization technique to address the mean shift, variance explode, or vanish on activations resulting from BN removal. The weights are scaled using the following formula. Meanwhile, two handcrafted scaling factors were introduced, while alpha controls the variance growth rate of the residual block, and beta regulates the activation distribution, constituting the primary source of multiplication in BN-free BNN. Gradient estimation techniques are used in binary networks to solve the non-differentiable problem. The gradient estimation technique uses the sine function to achieve binarization during the forward pass, and uses approximate gradients to achieve backpropagation during the backward pass. The same forward and backward calculations can be achieved using the proposed mask layer. The schematic diagram is shown on the right. The proposed mask layer combined with mathematical transformation can completely eliminate the multiplication operation introduced by beta. The equivalent operation process is shown in the figure on the right. Using bit operations for multiplication by powers of 2 is a straightforward and efficient technique, which relies on the binary representation of numbers and the properties of shifting operations. The quantized RPReLU structure enables more efficient bit operations by constraining its slope to be integer powers of 2. We conducted synthesis on various units using the Xilinx FPGA, and the hardware overhead is presented in the table on the right. For one convolution layer without pooling, the reduction in consumption for lookup tables, slice, and digital signal processors resources are 57.6%, 51.2%, and 100%, respectively. Experiments show that the proposed method eliminates multiplication operations with almost no loss in performance. Compared to the BN-free structure, we achieved a reduction of 15 million multiplication operations with an accuracy loss of 1.11% on RLeakyReLU, and achieved a reduction of 5 million multiplication operations on RLeakyReLU 18 while improving the accuracy by 0.9%. The proposed method is also compared with the mainstream binary network architecture on the small datasets, and shows good performance. The ablation studies were also conducted to show the effectiveness of each component. Experiments have shown that quantized RPReLU has better performance than fixed-slope RLeakyReLU. The value of alpha is also determined, and the results show that 0.5 is better than 0.1 to 5. The right figure illustrates the distribution of quantization slopes for the trained network, which quantizes RPReLU on 3 datasets using RLeakyReLU 18 and RLeakyReLU respectively. The quantization values are mainly distributed within the range of -19 to 6. For the small dataset CVPR, the exponential distribution ranges from -7 to 2, with a concentration around -3. For the ImageNet dataset, the quantization distribution is wider, ranging from -19 to 7, with approximately to peaks centered around -6 and 2. Thanks for your listening.